For principle of separation in HPLC, we have two mechanisms of separation in HPLC, which are normal phase and reverse phase. Okay, but before that, we look at the first sentence. When a mixture of components are introduced into the column, various chemical or physical interaction take place between the sample molecule and the particle of the column packing. They will travel according to their relative affinities toward the stationary phase, and the component which has more affinity toward the stationary phase, it will travel slower, and the component which has less affinity toward the stationary phase will travel faster. So the component that inside the column must be more than one component so that you can do um differentiation, or you can verify between several components, so you can make a comparison. That's why you use HPLC. Since no two components have the same affinity toward the stationary phase, so hence the components are separated. Next, we will look at the mechanism for HPLC. So for the normal phase, the stationary phase for normal phase mechanism is polar, okay, and the mobile phase is non-polar or less polar. Then less polar, non-polar or less polar than stationary phase, okay. And for the normal phase mechanism, the least polar compound will elute first. Means that the non-polar compound will elute first. Okay. For reverse phase, the stationary phase is non-polar and the mobile phase is polar, and the most polar elutes first. Okay, you must remember this between you must remember and know how to differentiate between these two mechanisms. In the normal phase mechanism, the stationary phase is here, which is the polar. Okay, so polar stationary phase contains of OH structure. Okay, and the compound is less polar. So the compound that composed of OH and O here, and also the benzene ring, and the OH component, it will retain more in the polar stationary phase, while the benzene ring and O structure, O compound here, will elute first, okay, compared to the OH compound that will retain longer in the polar stationary phase. Okay, we look at the second figure here, show the reverse phase mechanism, which is stationary phase is non-polar. So if the stationary phase is non-polar, the compound with most polar properties will elute first. Okay, so we can see that the structure composed of two benzene ring, and the benzene ring compound will elute first. Okay, I hope you don't get confused. Okay, we look at the explanation for normal phase first. In this column type, the retention is governed by the interaction of the polar of the stationary phase and solute. Okay, solute is the compound that you want to separate. For retention to occur in normal phase, stationary phase must be polar, more polar than the mobile phase with respect to the sample. Okay, so you cannot be both polar. You cannot make stationary phase polar and the mobile phase polar. So it must be in different polarity, so the separation can occur. And the silica or alumina possess polar site that interact with polar molecule. The components will elute in increasing order of polarity. And we can see that the figure here. So the one that is eluted out first is non-polar. Okay, non-polar, which is, for example, hexane, will elute first, and the yellow component here is most polar, because it elutes lastly. In the example of the stationary phase, which is the polar, is a silica. Okay, this is the mechanism drawing, which is you need to draw this mechanism figure if the question asks you to draw a mechanism together with a figure or diagram, so you need to draw like this exactly with a label, which is this one is the polar stationary phase, and this one is the polar molecule bind with the stationary phase, which is retained more in the column and eluted out lastly. And the purple one is the non-polar molecules, which is not bind to the stationary polar stationary phase, and will eluted out first out from the column. We can say that the stationary phase is hydrophilic, for example, silica gel or alumina backbone. And the mobile phase, which is non-polar, we call it as the hydrophobic compost, for example, hexane mixed with polar solvent. Okay, this one is the polar group content of silica and OH together with the O and O here. So the tips is most polar elute last, okay, and ataupun non-polar elute first. Okay, it is the same. For the reverse phase, in this column, the packing material is relatively non-polar and the solvent is polar. So the packing material is referred to the column, and the solvent is polar with respect to the sample. Separation is the result of the interaction of the polar components of the solutes and the non-polar stationary phase. And typical stationary phase we use are the non-polar component, which is hydrocarbons, and also sometimes we use waxy liquids or bonded hydrocarbon such as C18, C8, and etc. And the solvents are polar aqueous organic mixtures such as methanol water or acetonitrile water. And we can see the illustration here, because of the stationary phase is non-polar, for example, we use the carbon 18 material, and the mobile phase is polar, and we can see that the yellow component eluted out first inside the column, and it is the most polar component, and the blue one is the most non-polar compound. And the components elute in decreasing order of polarity, and the most polar will elute it out first. Means that the one at the behind is very decreased or low amounts of polarity. That's why we call it as decreasing order of polarity. From decrease to increase order of polarity. Okay, the one is the diagram for reverse phase. You just change the stationary phase here, which is non-polar. A non-polar molecule bind to stationary phase, which is with the with the blue purple compound. Okay, and the red compound is the polar molecule, which is not bind to the stationary phase and will wash out or elute out first. Okay, for example of the stationary phase is the non-polar hydrophobic. Example, liquid coated on a solid support, which is hydrocarbon, and the mobile phase, for example, water, methanol, acetonitrile. If the polar sites on silica or alumina are kept with non-polar groups, they interact strongly with the non-polar molecules. Okay, normal phase versus reverse phase. Mobile phase is relatively non-polar, okay, in normal phase. For example, hexane mixed with slightly more polar solvent like isopropanol. ethyl acetate or chloroform. And the stationary phase is polar, and the stationary phase polarity order is shown to the right. Okay, this is the most polar, and this one is the least polar. And this one, the outside, the blue here is the mobile phase, and the red here is the polar bonded phase, and this one, the outside layer is the silica or polymer support. In the reverse phase chromatography, whereby the stationary phase is nonpolar, we can see that the nonpolar bonded phase is here, and this one is the silica or polymer support, and the outside is the mobile phase, which are polar. Okay, mobile phase is polar. For example, water mixed with acetonitrile. Okay, and the stationary phase is non-polar, and the polar material we eluted out first, and you can see that the carbon 18 is the most non-polar and CN is the most polar. Okay, the relationship between the polarity and the elution time for normal and reverse phase. Okay, this one is the normal phase chromatography. Okay, for normal phase chromatography, the most non-polar will eluted first. Okay, means that the C component is most non-polar compound. So most polar elute, most non-polar, most polar eluted last, ataupun most non-polar eluted first. Okay, increasing polarity of mobile phase will decrease elution time in normal phase chromatography. As we can see here, medium polarity mobile phase. This one is the low polarity mobile phase. And in the reverse phase chromatography, the polar will eluted out first. Okay, means that the A will eluted out first, and then followed by B and C. This one is considered as medium polarity mobile phase. Okay. We have several choices of mobile and the stationary phase here. This one is the least polar. Okay, and the one is the starting from here is the least polar compared to the one which is the most polar. Okay. Most separation are achieved by matching the polarity of the analyte to that of the stationary phase. A mobile phase of considerably different polarity is then used. So how can we analyze the sample? We have a carbohydrate structure composed of fructose, glucose, saccharose, platinose, trehalose, isomaltose. So we can determine by using the Hplc instrument. We want to know which compound here 1, 2, 3, 4, 5, 6 will eluted out first. Okay, separation is based upon the differential migration between the stationary and the mobile phase. First, the stationary phase, which is the phase which remains fixed in the column, for example, C18, silica. In the mobile phase, we carry the sample through the stationary phase as it moves through the column. Okay, we can see that from the beginning. Okay, the injection process, sample will pass through the column here and will be detected on as a chromatogram peak here. Okay, from the chromatogram, we can determine the retention time. T0 is dead time. Okay, TR retention time, and the area or height is proportional to the quality of analyte. Okay, this one is the modes of separation applications.